Hi, this is an example problem from Chapter 17, a second example on interference of sound waves. Pause for a moment and read the problem. All right, so we've got two loudspeakers, and they are going to be directing sound waves to a listener. We know how far away the two speakers are from the listener, so we can calculate the path length difference. Again, that's going to be L2 minus L1, the path distance between the speaker to the listener and the other speaker to the listener. Take the difference. Now it doesn't matter which one we take to be L1 and L2 here, so I can choose whichever. I'll take the bigger one to make it positive. But in this problem, we are looking for the lowest frequencies that will produce constructive interference or loudness. So if we go back and look at our equation, for constructive interference, we have m times lambda, the wavelength, where m is an integer value, 0, 1, 2, 3, etc. So we can write that down. This is the form that we want. M times lambda. Now actually we want to know about the frequency here, right? What are the two lowest frequencies that can be heard? Well, again, we can relate frequency to wavelength. And so the fundamental equation, the speed is equal to the wavelength times the frequency. The frequency, or the wavelength that we solve for, right, it's going to be equal to v divided by f. And in this problem, we know what v is. So we've got 343 meters per second, the speed of sound, divided by the frequency. And we can plug all these things into our equation now. So L2 minus L1, let me take that to be 50.5 meters, the one path length, minus the other path length, 26 meters, is equal to m, and then we're going to put this in here, the 343 meters per second divided by f. And remember that m can have values here of 0 or 1 or 2, etc. But for the listener to be able to hear these, the frequencies got to be the lowest, but they also have to fit within this range. So if it's less than 20, it won't work because you can't hear it as a human. Let's solve for f and see if we can figure that out. So a little bit of a math here. 50.5 minus 26 meters gives us 24.5 meters, and that's equal to m times 343 meters per second divided by f. Let's go ahead and solve for f, and we'll leave m in there. So bringing the f to the other side and leaving m there, and then we have basically 343 meters per second divided by 24.5 meters. This will, of course, give us frequency because we cancel the meters out. And a little bit more math here. Let's just calculate that. 343 divided by 24.5, and we get a value of 14. So it looks like f is given by m times 14 1 per second, or 14 hertz. That's 1 per second, right? Now we're going to go ahead and just start plugging in the, looks like the lowest values of m here will produce the lowest frequencies, right? However, m equals 0 gives us a frequency of 0. That doesn't work at all. M equals 1 gives us a frequency of 14 hertz. That is too low. It's below 20. M equals 2 is going to give us 28 hertz, right? So that will be okay. So let's go ahead and just put those in there real quick. So if we have f when m is equal to 2, let me just write that like this, then we've got 2 times 14 hertz, and we get a frequency of 28 hertz that leads to constructive interference. So that's the lowest that you can hear. The second one is going to be when we put in the next integer value for m. That'll be f3. It's going to be 3 times 14 hertz. And if we calculate that, we're going to get 42 hertz. That's the next lowest that we can hear. So the two lowest frequencies in this range that you can hear that are going to produce constructive interference, 28 hertz is the lowest, 42 hertz is the next lowest that a human being can hear within the ordinary range of 20 to 20,000 hertz. As an aside, an interesting aside, anything less than 20 we call infrasonic, and anything above 20,000 is ultrasonic, without outside the range of human hearing. Of course, this number is just an average, right? For younger people, 20,000 hertz, some people can hear above that. As you get older, that number goes down and down and down as your hearing gets reduced to lower frequencies.